Today we are jumping into one of the most intense and frankly most philosophical debates currently gripping the decentralized world. It's this technical fight over how Bitcoin transactions are processed and, well, what precisely constitutes spam.
Yeah, it really sounds like just a technical argument on the surface, like just optimize the code and stop the junk mail,
Yeah.
right? But what our source material reveals is that this isn't really about code efficiency at all. It's about a fundamental schism, a split in the community.
Right. It forces us to ask, what is Bitcoin fundamentally for?
Exactly. Is it supposed to be this pristine monetary network, or is it more like a general-purpose decentralized data platform?
Okay, let's unpack this then. Our mission today is to deep dive into an expert analysis that seems highly confident that there is a massive misunderstanding between developers and users on this whole topic. And their central argument is that transaction fees are, like, bar none, the only solution to spam that actually works with decentralization. Anything else just breaks the trust model.
Exactly. And we start with a shared goal, right? Everyone wants to improve Bitcoin as a functional global system. That's not the debate. But the philosophical divide kicks in immediately. If you treat Bitcoin purely as a monetary system, as our analysis argues you should, then economic friction fees, that's your defense.
Makes sense.
But if you treat it as just a cheap data storage system, a ledger you can just write anything to, then the author suggests you might not really grasp the necessary trade-offs, the hard choices you have to make for truly decentralized networks.
Okay, that sets the technical framework perfectly. Because Bitcoin is supposed to be this neutral, trustless money. How do you defend it? How do you stop a denial of service attack or just a massive spam event?
Right.
On the normal web, the centralized web, we throw up all sorts of barriers. CKBTCHAs, required logins, email verification, you know the drill. So it seems kind of intuitive to just adapt those centralized filtering ideas to Bitcoin and block the unwanted data. Why is that solution apparently so dangerous here?
Well, the problem is that every conventional method, pretty much every single one you can think of for spam prevention, relies almost by definition on trust and centralization. The experts whose analysis we're synthesizing today, folks who've spent years working on anonymous and decentralized systems, they're really adamant about this. There is just no known method to prevent sophisticated spam in an anonymous open network unless you introduce either economic cost or some kind of central gatekeeper.
Okay, so let's look at those traditional examples the source uses. They really illustrate this breakdown of trust. Like, take the common CAPI-CHA, the click all the squares with a fire hydrant puzzle.
Yeah, the CAPI-CHA, it's basically centralized proof of work, but for humans. It slows the user down, sure.
Yeah.
But the key mechanism isn't really the puzzle itself. It's the fact that Google or Cloudflare's central server has to verify that your solution is legitimate.
Oh, right, the check.
Yeah.
Yeah.
If you tried to run your own CAPI-CHA server, nobody would trust. You weren't just cheating the proof of humanity test, right? It inherently requires you to rely on a massive, trusted central entity.
And logins and email addresses are kind of the same deal then.
Pretty much. They only work because there are centralized choke points. Internet service providers, big email providers like Google or Microsoft, that control how hard it is to create a new account. Maybe they require a phone number, whatever.
Okay.
If Bitcoin really lived up to its decentralized promise, anyone could theoretically spin up 1,000 verified accounts instantly, and the whole identity-based filter system just completely collapses.
So it doesn't translate?
Not at all. And this brings us to the analogy that's probably most relevant for Bitcoin developers. Content filters. Like ad blockers.
Ah, okay, ad blockers.
Ad blocking is this constant, exhausting game of cat and mouse. It only functions because there's usually a dedicated organization constantly updating its filter rules, and crucially, users trust them enough to download those new rules every day or week.
And we've all experienced the failure mode there, haven't we? You install a sophisticated filter, and then within weeks, the advertiser or the website figures out some new way to get around the rule, and poof, the filter fails.
Exactly. You need a new set of rules constantly.
So apply that directly to the Bitcoin mempool, the waiting area for transactions. Suppose a developer creates a filter targeting transactions that use a specific setting, maybe a lock time value of 21, because some project is using that field to, I don't know, smuggle data or spam the network?
Okay, yeah.
Wait, just quickly, for listeners who aren't maybe deep in the weeds, what exactly is the lock time again?
Good question. Lock time is basically a field in a Bitcoin transaction. It specifies the earliest time or the block height at which that transaction can actually be included in a block. It's normally used for things like time locks or maybe more advanced contract functionality. It's quite flexible.
Got it. Flexible.
So if a spammer is using a lock time of 21 and the filter blocks 21, well, the spammer just notices that. They change the value to 22 or 23 or 100, whatever, and the filter is instantaneously back at zero utility. Useless.
The filter is immediately obsolete. It's just a temporary inconvenience at best.
And that leads directly to the critical danger the source highlights. Where did you actually source the updated rules for every single node on the network?
Yeah.
You would need to trust some centralized authority, or maybe a specific governance body, to constantly publish those filter updates. And then every node runner would have to download and integrate them, probably daily.
That sounds like a massive bottleneck.
It is. The source warns that this is profoundly concerning. It grants the filter providers immense power and, crucially, requires immense trust. It effectively transforms Bitcoin into a kind of centrally planned system, which is the absolute antithesis of why it was created in the first place. Filters inherently require human centralized intervention. They just cannot be trustless.
Okay, that distinction really clarifies why filtering seems like a technical dead end for Bitcoin. It introduces the very single point of failure, that trust requirement, that Satoshi's original design sought so hard to eliminate. So, if centralized filtering is fundamentally incompatible with decentralization, what is the alternative? And this is where, I guess, the genius of the original design really comes into play.
Precisely. If you can't rely on human identity or some central authority to provide the necessary friction, you must rely on friction that's baked into the economics of the system itself. And that is the genius of the integrated system of proof of work and transaction fees.
Okay, here's where it gets really interesting for me. How exactly are proof of work and fees integrated like that as an economic defense? Because, many people tend to see them as kind of separate components.
That's a common view, but they really work together. Think of them as two layers of sort of inescapable economic cost. Proof of work's primary role is to enforce the global constraint. It slows down block production to roughly 10 minutes by requiring just massive energy expenditure.
Right, the mining costs.
Yeah, this makes the acquisition of the resource, that valuable block space, extremely costly. Without that cost, a spammer could theoretically just generate 1 million blocks instantly and overwhelm everything.
Okay, so that's the macro cost, the energy input side.
Correct. Now, once a block is produced, how do you manage congestion and decide which transactions get in within that resource-constrained block?
Fees.
Fees. You use the monetary unit itself, sats, which were originally earned, ultimately, from the proof-of-work process, and you spend them as a transaction fee. The fee enforces the microcost, the cost per transaction. This whole system defends itself from denial of service, because every single activity, regardless of its content or who sends it, costs real, provable resources.
So fees are essentially the ultimate economic spam filter. They're totally neutral. They don't care if you're writing a legitimate financial settlement or just embedding some junk data. They only care if you're willing to pay the market price for that global, trustless confirmation.
That's basically it. And this is, as far as we know, the only way to fight spam effectively in a truly anonymous, identity-less system. Bitcoin doesn't need to figure out if you are one person pretending to be 1,000 or 1,000 genuinely separate people. Since the cost is set by market competition for that scarce block space, the system is defended automatically. If spamming becomes too expensive, it just stops.
Okay, but doesn't the solution, inherently introduce a different kind of centralization? If the economic solution relies entirely on costs, and if block space stays persistently scarce, doesn't that just lead to a system where only those willing or, maybe more importantly, able to pay potentially exorbitant fees can actually use it? Doesn't economic friction sort of defeat the universal accessibility goal? Doesn't it make it centralized by price, effectively?
That is a critical challenge, absolutely. And it's the core trade-off the source readily acknowledges. The price of neutrality is friction. If you try to lower the economic friction down to zero to achieve, say, universal access for everyone, you simultaneously lower the friction for denial of service attacks and spam down to zero as well.
Oh, okay. Can't have it both ways.
Pretty much. The author argues forcefully that you have to choose. Either you accept the economic reality that secure, decentralized, neutral processing comes at a price, and that price is determined by market demand. Or you reintroduce centralized filtering and governance, which, might make it cheaper in the short term, but it eliminates the core value proposition of the entire system. You lose the trustlessness.
That is a harsh, but maybe necessary assessment of the trade-off. And this leads us directly into the recent controversy, doesn't it? Developers, specifically related to Bitcoin Core, have been slowly relaxing certain older mempool filters, and this has caused this massive public outcry. Critics are claiming this is some kind of attempt to intentionally turn Bitcoin into something lesser, a shitcoin, as some put it.
Yeah, and we really need to clarify the technical purpose behind relaxing those specific mempool rules. The Force explains very clearly that this relaxation, which by the way has been discussed and debated for years, is absolutely not intended to assist questionable transactions or open the floodgates to junk.
Okay, so what is the real technical reason then? Why do it if it causes such a fuss?
The real problem being tackled is the operational burden that these outdated, often complex filters place on node runners. Imagine your node having to check dozens of complicated, maybe arbitrary rules that might not even be relevant anymore because spammers already changed their tactics ages ago for every single transaction that comes through.
Right, that sounds computationally expensive.
It is. It increases memory usage, it adds computational overhead, and it slows down the whole transaction validation process.
So the filters themselves can almost become a sort of denial of service vector against the node runners because the validation logic gets too complex.
Yeah. Exactly right. So the goal of the relaxation is simply to improve the node's prediction of what will actually be included in the next block, make things run smoother, and reduce the overhead of maintaining this constantly failing, often unnecessary complexity. The claim that this is some intentional shift to benefit, shitcoins or whatever, fundamentally misunderstands the engineering priority here. The focus is on improving the system's efficiency for its primary monetary use case.
Okay, that context is important, but let's play devil's advocate for a second, using that core economic counterargument mentioned in the source material. What if the economic demand for decentralized data storage, the non-monetary, maybe data smuggling use case, what if that demand turns out to be fundamentally higher and more persistent than the demand for pure monetary transfer? If people are willing to pay astronomical fees just to embed art or metadata or whatever else, how does the system, which is trying to be money, actually cope with that?
That's a deep question, and the author delivers a really powerful philosophical response at this point. They basically suggest that if you genuinely believe Bitcoin can't succeed as money, if you don't think the monetary use case is competitive enough on its own for people to be willing to pay transaction fees for it, then why do you even care about the system persisting in the first place?
Tough point.
Yeah. If the system's value becomes entirely dependent on subsidized or artificially cheap data storage, then it hasn't actually achieved the kind of resilience Satoshi originally envisioned. The argument is the system must be able to sustain itself through the economic demand for its primary intended monetary use case.
It really brings everything back to that foundational belief about what Bitcoin is and what it's for.
It absolutely does. The ultimate choice is laid bare, really. Either we centralize and impose human governance through filters, or we pay the price of true decentralization through economic friction. There is no free lunch, no easy technical fix that avoids the need for cost in a truly neutral, anonymous system.
So recapping, we've pretty much established that relying on constantly updated, trusted filters introduces the central point of failure, and it fundamentally violates the core design principles of Bitcoin. Okay. The cost of participation, enforced through fees alongside proof of work, is the only true censorship-resistant spam filter that actually aligns with those principles.
And that neutrality aspect is absolutely key. An economic filter, like fees, is completely indifferent to the content of the transaction. It only registers the economic cost, the willingness to pay. A centralized filter, however, can always be pressured or compromised or even legislated to censor specific types of content, rendering the network unusable for those who rely most on its neutrality.
Okay, so what does this all mean for us as users then, day to day?
Well, I think it means that every time you pay a transaction fee on Bitcoin, you aren't just, paying for speed or confirmation. You are actively reinforcing the system's security, its defense against those DOS attacks, and maybe most importantly, its neutrality. You're essentially paying the price required for trustlessness.
It's a necessary cost, not just a tax or an inconvenience.
Exactly. A feature, not a bug, you could say.
Absolutely. Which leaves us with this final, maybe provocative thought for you to consider. If the only way to maintain that absolute neutrality and prevent censorship effectively is through this economic friction of fees, how does the community, how does Bitcoin ultimately balance the goal of being universally accessible, inclusive money with the simultaneous, apparently unavoidable, necessity of making activity costly enough to deter highly motivated global spammers? That seems like the fundamental trade-off we'll be living with and probably debating for the foreseeable future.